Welcome to the Festo press conference. We are here at Festo headquarters, where Festo researches and develops all the new technologies. The Hannover Fair begins on the 1st of April under the motto Integrated Industry, Industrial Intelligence. We took a look at some of the topics that are particularly interesting for you there. For example, how does artificial intelligence change tomorrow's industrial production? And everyone is talking about autonomous driving. Will industrial production also become autonomous in the future? Today I'm talking to 4 Festo experts here. Welcome to you.
Thank you.
About these super nice questions we have there. And Mrs. Krüger, you studied theoretical computer science, and in 2003 you founded Risolto Informatik GmbH, which is part of the Festo group now since 1 year. What was your motivation to found years ago?
Well, you know, at that time it really just felt like something I had to do. I came from this very technical family. My father has always been working in industry. Yeah. Even my mom, she was introducing technological systems, and I had this very theoretical background now. Yeah. So I saw what algorithms can do. I saw what artificial intelligence can do. So I thought, well, I have to somehow get that together. I have to really bring all those goods, all this potential into the industry, and I just wanted to work with the engineers.
Thank you. Dr. Melzer, you are member of the management board at Festo and head of the Industry 4.0 Platform Steering Committee for the digitization of business in Germany. That sounds great, but let me ask you, what role does artificial intelligence play there?
Well, thanks. Artificial intelligence plays the key role for a lot of areas, including industry, but also our daily life, healthcare, banking, public sectors. It changes a lot of processes and things how we do dramatically. Government of Germany developed a artificial intelligence strategy last year, and within the platform Industry 4.0, this is one of the key topics. Yes. How we foster that for industry, how we increase productivity, and what are models to use that. This is what we discuss in this industry community. For Festo, for us, this is a key enabling technology to make our products in the future not only smart but intelligent and offer more clever services to increase productivity for our customers.
Dr. Knubben, you have recently become Head of Innovation and Research, and at Festo this includes also the topic of bionics. So let me ask you, what impulses from AI come from nature?
Yeah, actually we learned quite a lot within the Bionic learning network within the last 10 years. Mm-hmm. So we did research in the ants, for example, and came up with decentralized systems that work together, that collaborate together. Also, we did research in swarm behavior where we can learn from. And recently we have a look into neuronal networks where we also can use these artificial intelligence technology in order to solve complex problems in in-hand manipulation, for example, as I will present later on.
Okay, 4th in the round. I welcome Dio Satikidis. You are an AI expert working at Festo, and additionally you're giving lectures at the University of Esslingen as well as London. So can you give us an insight how do you experience the topic of AI at universities? I mean, is it also a hype topic there?
Not just a hype, but it comes really, really strong in lectures and in universities, because it's a paradigm change. How we go far away from just manually programming stuff into the new age of training AIs, which solve problems for different applications. And this paradigm change is important to teach and to bring really, really in the early stage of education.
A question that concerns many companies: where do we stand with AI in automation? And as we can see behind us, you prepared a little presentation. Yep. So let me ask you, what do you think, how smart are machines today and how do they learn?
Yes, so I will tell a story about how AI will change automation into autonomy. First, I will address how programmers implement software today. So we have a kind of input like this image data here, and we have a program which is handmade. We feed that inside a computer, and this computer gives us output. For example, I detected this cylinder. AI will change that. So AI will have an image data, for example, which is still the same, but it will have the output, which is the aim to detect. And a computer will calculate an AI which can solve this task. So these two parts are called data, really formally. And I can take this AI, deploy it to machines, and transfer the skill. But what will be the evolution of that? We will take a look in the steps, and I will use an example how newborns learn. First, I have in the machine learning domain from data the perception ability. Perception means, for example, regression. I can create the ability, which I have a square, dot, and I can guess what will be the next. Or I can say, wait a minute, in this cluster, I have something different. So it's an anomaly. What we will see also in the machine, which is presented here. Or I can say, how I can detect and separate clusters. I don't know if these are dots or these are squares, but I know I can detect from data, this is different and belongs together, and this also too. After machine learning, I need a kind of memory. This is the step of deep learning. In deep learning, I have the ability to take the algorithms from machine learning and cascade them. And with the cascadation, I can create, with the perception and input data, a multi-layer architecture which can detect, for example, three-dimensional objects, like the cylinder, the cube, or even a face. So each layer of that has its own task, detecting a small piece of the whole. On deep learning, I have the challenge that I need a lot of data. So how I can create a lot of data, how I can create, for example, dexterity, solving a task, if I have to teach a lot of years, which was made, for example, by me in my lifetime, how can take this time back? And in this point, reinforcement learning comes into the game. So in the reinforcement learning, I have, after the perception or memory, the dexterity which is created. If I couple together an actor, an AI, but also the task. I can do it in the simulation with a digital twin, for example, with this cylinder, placing that on this cube, and I can learn lots of years of evolution, what I have also learned as human, in the machine way, but I can learn that in a really fast time. If I want to transfer that to the reality, I can take this AI and put it in the reality, and I can do the same task as learned in the simulation. Here I have the problem that if I just little change the task, I need a completely new training. Actually, the state of the art in AI is solving the challenge of transferring the intelligence. So this is called transfer learning. And it is the point of, after I have perception, after I have memory, after I have dexterity, I need a kind of abstraction. And abstraction means, if I teach one times machine to place the cylinder, I can also transfer this skill, for example, to place that form also like this. And this will be the last step for autonomous machines.
Thank you for the insights, Mr. Sadikidis. Before we go deeper now, would you be so kind to give us a short personal impression about AI? So what's moving you on this subject right now?
Well, for me, it's very impressive. AI is everywhere. It's not longer a buzzword on fairs, but it's everywhere. It's in our daily life. It's on our mobile phone. It's on our car. And I've seen it. Consumer electronics shows many, many applications in daily life, like TVs to enhance picture quality. So despite the impression of Dio that this is a theoretical thing and is far away for us using it as an industry, it's already at border. It's there. We want to make use of that very quickly, and that drives me every day, how we bring that into industry life.
Thank you. What do you think?
Yes, as Mr. Meltzer just quite rightly said, it's such a huge range of things we can do now with artificial intelligence. And for me, it's very exciting to see how much we can do in Germany and how far we are in Germany. You see, there's America doing great artificial intelligence. We see Google and things like Alexa, everybody knows, you see, but we here, we have the industry. We are very close together with the industry, which is extremely strong. We are world leader in industry. And if we manage to really get excellence in artificial intelligence for the industry, this will still be leading. This is something where we are very good and where we are very hands-on and very far advanced already.
Yeah? Let's ask our AI expert there.
So my opinion is we have to apply AI. That means we have to create AI by our own. Just a mind which creates AI by them own, it has the ability to create new ideas and new innovation, solving a task for the future. And for that, we need to own that and to create that in our company.
What do you think?
Yeah, I see big potential as well in this human-machine collaboration. So as we showed last year with our future concept, Bionic Workplace, for example, AI can enable us to really work very intuitive together with the machine or with the robot. So we can use gesture control, we can use voice control, we can have image processing, all these things that enable us to finally get much more better assisted by machines in the future, which increases productivity and also the ergonomic way of working in the future.
So let's go deeper in technology. AI, I think we all agree, is all about data. So what does big data mean in terms of automation? Is it no longer possible without cloud, for example?
I have to disagree. There's so much cloud talk going on. I mean, the cloud is a marvelous technology. It's great what we can do with that, but it's not the same as AI. They don't even need each other necessarily. So what we see in automation is, well, we have a real-time application, so it's all about speed, and we have a massive amount of data. So why transfer all this data of an expensive infrastructure, which will only take latency, it will cost time? Why not interpret it there and then where the data is happening and where it starts to be created by the measurements? So what we really enforce is the edge computing here. And we developed our software straight away to be able to do the interpretation on the edge level. So cloud is a great thing if you want to do adaptive learning, if you want to be on a meter level, looking at all your production plants. But the real interpretation of, well, how is the health system of my machine? How can I do the optimization just there and then? That really has to happen on edge, and that is where we are particularly strong.
Yeah. Good thoughts. So, what's your opinion there, Mr. Meltzer?
I just can reiterate or reinforce what Tanya said. We have the cloud, and there are a lot of things in the cloud, and we will need the cloud future. And we work at Festo on our own cloud services, but also on many other major platforms. We offer IoT services there, and some are new and will be shown in Hannover Fair. But the tendency is very clearly, and we made a good step last year with Risalto to move that more closer to the machine. First of all, on premises, and at the end, directly on edge computing in the machine. To offer the same technologies, the same services closer, with the advantages of real time and less data traffic on the IT networks. And if you imagine, we probably use only a small fraction of the data today. And if you would get all the data through the network, we will not succeed. So there will be a big trend towards using that much closer to the machine, offering our customers much faster analysis and directly there where the data existing, we analyze it, less topics on data integrity and data security. And we think this is clearly the tendency for the future.
What products does Festo develop with AI, and which will be shown in Hannover?
Well, many. I would say tons, but this is
Why not?
this comes still from the aluminium times where we have these heavy stuff. Now it gets much more electronic, much more software. So still a lot. We came up a couple of years ago with Festo Motion Terminal showing a digitalization of pneumatics. There we have sensors, intelligence, and we get the data. You have E2M, air preparation unit. We showed last year this little nice product. Looks not too sexy, but it's really cool because it's the connection to the internet, and it's the so-called IoT gateway where we have computing power. The future will be that we run a lot of these services and analysis on such a device there. And this year we show dashboards for cloud, which will move further on to on-premises, and we show really nice examples on how artificial intelligence can be implemented on our CPX control units, and first nice demo examples how we use that.
Yeah.
So a whole scope from the bottom, from the field level, all the way to the cloud level will be shown at Hannover Fair.
Yeah, you're both playing such a nice ping pong here, so let me ask you, any additional thoughts there, Mrs. Krüger?
Well, yeah, there's something I have to show you because I brought especially this very cute little steaming engine, and obviously it's not something we are going to show on the trade fair. But what you can see very clearly here is how easy you can set up an existing machine, an existing system. And make it intelligent. So all we have here is this steaming engine, a little heart opener for all the engineers, probably having played with that at Christmas sometime. But we installed these vibrational sensors, very sensitive sensors, and their signal is going directly into this little control unit. And on purpose, we didn't choose a Festo thing here now to show, yes, we can run it also on existing hardware. It's something you can very easily refactor. And this is so intelligent now, it does not only recognize what you're doing, so if I would snip off something here or irritate it somehow, it would tell me what I'm doing. After a while, it could also recognize the cleaning personnel we have, because it recognized the steps it made. So there's so much you can do really in an easy way, and the architecture is easy and really affordable.
Do you have concrete use cases for us? So let's say first examples for the use at the customers?
Yes, there are a couple of examples, and one is very nicely because it's about clamping. And clamping was the step for Festo to move into pneumatics technologies in the 50s, because you could see with pneumatics you can apply much more force and to clamp at that time wood. And we do a lot of clamping in automotive industry to hold the pieces together. And these clamping mechanisms we could show with artificial intelligence by collecting data that we could predict failures much earlier, coming from a accident-oriented maintenance to a plant maintenance in breaks or in a typical maintenance period, saving a lot of efforts on one hand, but also reducing the risk that a line goes down because of a simple clamping mechanism and lose a lot of productivity. And this is a nice example for me because it's the origin of pneumatics, and it's also connected now with artificial intelligence for our next step. So it makes even so-called old technology very fashionable and shows how much more we can drive as a benefit for the customer with combining these technologies. And it's in actual mass production today. So it's at our customers live.
Yes.
I mean, even if you take the years before we became family now, we've been doing about 200 use cases by now, showing all those little fields where AI is doing something good. And it's not only the predictive maintenance we're always talking about, it's also the optimization of quality, for example. If you do not have so much loss, not so much throwaway in the end, that saves an awful lot of money as well. Or if you have a faster production cycle, that can really save a lot of money as well. So there are so many things.
Great. We have some questions from journalists here for you. Question number 1, intelligent machine maintenance. Is Festo already building prototypes? Or are there any customer deployments yet? Answer?
Yeah, another example of automotive industry, an industry which is very much productivity and cost driven. So early adopter of new technologies which save cost and increase productivity. There we have an AI application with Risolto software and Festo the product technology for welding guns. And the problem is if the weld is not okay or the welding gun fails, you lose a lot of productivity time because the whole line has to go down, has to be disassembled, replace the welding gun and then restart again. You lose a lot of time. And with artificial intelligence and all the data available, we could show that we could, first of all, predict that much earlier. Secondly, we could collect more consistently worldwide data, and all the plants of that customer worldwide can collect the data and show the data in a consistent form. And then in central processing, they could compare how good shape these different welding guns are. And for them, it's a great productivity increase, risk reduction, and a step forward in using this technology.
So, second question from a journalist there. Maybe I will ask you that, Mrs. Krüger. Can a medium-sized company afford intelligent machine maintenance, and is it worth it?
Well, I guess even a small company could, not only a medium size. The thing about automation and its tools is always about saving money or earning more money. Yeah, so it's all about a cost, of course. And well, you have to ask yourself, if you have a machine that has dramatic failure every so often and costs you a lot of money, it may still be or already be worth it, really. The thing is with AI, you don't have a great starting invest. It's something that you can just pay per month in really small charges. And if you see that it is doing something good, you can carry on, or otherwise you stop doing it. And well, if you take this optimization case I was speaking about before, or if you look at all those companies now that are renting their machines out, it's more like a service model now, where you do not sell the machine, but you say, well, okay, I sell you what the machine does for you, but then you are in a guarantee case. So you need all this transparency over your machine park yourself. And if you have a guarantee case, it can be very expensive indeed. So this is something that can even be working financially for very small companies as well.
So we can see it's financially feasible, point. But how do companies need to change in order to get fit for the networked production in the future? What would you say?
Well, I think you really have to open your mind. What I see in industries is a very conservative attitude very often. And looking at what you just explained in this technology, it's a totally different approach. So you have to allow yourself to learn something new. You have to maybe also take colleagues in that have a totally different background, maybe a computer scientist for a change. And yes, you have to work in a more networked way, all in all.
May I ask you, would you give us a look behind the scenes? How do you develop all these new technologies? Or ask them around.
For us in engineering and R&D, the one big change is that we get much more technologies moving in. We not only have the mechanics, either pneumatics or electric, but we have much more sensors. We have intelligence, we have software, with the combination of all that in different paces. So we work much more in interdisciplinary teams, we work much more in agile structures, and we have to look much more for the driving technologies, because there's a lot of intelligence behind that. So we work a lot with semiconductor companies worldwide, and also stretch out to figure out what's the next step in AI. how we can make our products much more intelligent and much more benefit for that. So it changes quite a bit to the benefit to deliver these products to our customers quicker than anybody else.
Okay.
So for doing that, we work very close with startups together. We have one time in the year startup night. We invite their startups. They show us their products, and together we focus how we can integrate that products on our hardware products and create value for our customers. This is really, really exciting. And another point where Festo started is the Applied AI initiative, which is created out of the Unternehmertum in Bionic, which has the focus to provide also capacity for computing AI and also know-how transfer on the technology level. And this is really exciting.
Dr. Knob, do you have an example for us? How do you develop a new technology here?
Yeah, in Bionic Learning Network, again, we get inspired by nature. We work in interdisciplinary teams together with external partners, universities, also startups, development partners all over the world. And I have one nice example. Actually, in 2015, we have presented the so-called flag-shaped gripper that was inspired by the chameleon's tongue. Maybe you remember. And this year we come back at the Hannover Fair with the final catalog product. We had a lot of pilot customers over the last 2 years, did a lot of improvement, and now finally we are really happy to introduce it into the market, looking forward to solve complex needs of our customers with this product.
Well, I think another very good example of such a collaborative work is Scratech itself. So if you see how Scratech really happened in those days, it still had, of course, a different working name, but we had 6 huge scientific research programs connected with that. And there was the scientific institutes like the Fraunhofer IOSB in Germany that worked with us on this. And there was Miele, it's also close to our company. And then we have those huge manufacturers of connectors like Phoenix Contact, Vago, Harting, and they were all part of this. So we already had a very scientific and very AI product that was straight away tested in the industry, and they all had their hands at it.
So talking about grasping, this is an important function in the automation technologies. Do you present something at the Hannover Fair there?
Yes, again, grasping was an important topic of the last years, and this year we came up with the hand, the Bionic soft hand, which is inspired by the human hand, as you can see. And here we have fingers that are made with 3D knighted textiles that we actually fill up with compressed air, and this leads then to a bending movement, so 12 degrees of freedom. We are also able to switch the thumb and to use the index finger with 3 degrees of freedom. And we have equipped this hand with sensorics. So here on this side you see inertial sensorics that we use to measure the position, and also we have force sensors inside the hand. And the clue actually is that we use artificial intelligence to train the hand, that finally it is able, using reinforcement learning, to manipulate a ball or an apple, or in our case such an object, and this was made with reinforcement learning and with a digital twin. So as my colleague in the very beginning already said, it's very important to speed up the learning. Therefore, we use 3D cameras, depth cameras, to measure the positions of the finger, to get the model of the hand, and then learn using massive parallel learning in a virtual surrounding.
So I really love that hand there. And by the way, may I tell you, I'm really a fan of your Bionic videos. So may I ask you, because I can imagine that also some of our viewers are as well excited as I am. What other Bionic projects do you present this year?
Yeah, for a hand you also need an arm. So first of all, we show another arm, which is also made with these 3D knighted textiles, which allows us actually to build a really lightweight structure, which also has the potential to be very cost effective. It's compliant and therefore can be used very well in this field of human-machine collaboration, as I mentioned before. And it's designed in a modular way, so we can build up a 7 degrees of freedom arm, or, for example, as well as Kara, that is able also to move around objects which are in the field of action.
What about animals?
Yes, you're right. I almost forgot. But as every year, we also have an animal with us this year. It's called Bionic fin wave, actually, and it's an underwater robot using undulating fin movements to swim through a pipe system, actually. And as well, we have ultrasound systems on board, so we can measure the distance to the wall of the pipe and therefore are able to swim fully autonomous through the pipe.
Sounds great. We have now looked to the future, what it will be possible. The question remains, will man in the end become superfluous and maybe replaced from technology, biotechnology?
No, I don't think so. I think the human is even more important than ever, but automation, in particularly artificial intelligence, will make life easier. The boring, repetitive stuff will be taken over, and effectively it gives back us time. Gives us valuable time back to focus on the things we can do even better. This is all about teamwork, creativity, and empathy. This will be very, very difficult for these machines to copy us there. But they can take off, as I said, the repetitive work and make then productivity better. What is really the case is this is a lot of technology, as we discussed here, coming up in a fast speed to us. There's a lot of change in competence and knowledge. It starts with me and goes all the way down to the workers. And this has been always happening in industry development, but this time things go much faster. So we have to prepare for that. That means, starting with me and all of us, we need to learn, we need to adapt to these new technologies. We not only need experts, but we also have to take our people to the next level. And we at Festo, and also in that Industry 4.0 platform, education and lifelong learning is one of the key topics. And Festo Didactic provides a lot of possible uses how we do that in industry, ranging from lab equipment all the way to digital courses. And we think that combination for us, delivering products, services, but also the educational part, will bring us forward much more quicker. And I just can iterate. The human will be the important part in that, and we will make life easier for the workers, for us, and for our customers. And this is the quest for Festo.
Thank you very much to all 4 of you for these inspiring insights. And also thank you very much to our viewers for spending time with us here. And please feel free to write us or call to us if you have any questions. And naturally, you're very, very welcome to visit us in Hannover at the stand of Festo. And I'm going to go now virtual to the Festo stand in hall 15D11. See you there.